Well, I'm John Tyler Moore, and I'm an environmental and natural resource engineer.
Hi, I'm Kyle Kiefaber, and I'm an environmental and natural resources engineer as well. Okay, so basically, our project's going to deal with the Purdue Agriculture Center in Montauk, Indiana. And what happens is they have two fields up there that are high in organic matter, organic content. And basically, the current ditch system they have working doesn't adequately control the water table. And so our project sponsor, Stephen Hawkins, gave us a project. We had to come up with a design to properly control the water table at certain levels during various seasons or crop rotations. And a bunch of his constraints were it had to be cost efficient as possible, it had to be easy to manage or implement, it had to obviously maintain the water levels. And a big thing he wanted to do was avoid use of concrete and heavy excavation. So it kind of limited us to the designs we needed to do. But ultimately, what we chose was the use of a flashboard riser design with a aluminum piling retaining wall.
The aluminum piling retaining wall is anchored 2 layers to themselves and then filled with a silty sand backfill. And this is going to seal off the ditch and force all water to flow through the flashboard riser. The flashboard riser will then control any water table to any desired height to help prevent runoff and subsidence of fertilizers, subsidence of the soil, which causes inch loss of the topsoil and nutrients as well, subjecting the soil to water erosion and wind erosion. This structure will protect the downstream watershed of the Kankakee River Basin and then later all the way to the Mississippi by preventing fish killing levels of nitrogen, phosphorus, or potassium from building up and causing hypoxia, overgrowth of algae, or killing the fish outright with pesticides or herbicides. The economic impact of this particular structure will allow you to hold the water table up in your field to provide optimum nutrient uptake for the plants so that instead of flushing water through the system and it takes with it nitrogen, phosphorus, and potassium, instead you're holding it in the soil and maximizing the time that the soil is exposed to it so that the plants can uptake it efficiently.
We had a couple alternative solutions. What we thought initially we might use was a sluice gate or a weir gate system, which effectively just raises and lowers the table. But ultimately, the flashboard riser system allows you to more accurately control the water tables. So, and an item like that, like a sluice gate option, would just be much more expensive. And then even though our system seems expensive, in comparison to some other designs we've looked at, it's a lot cheaper. And the materials we've used are ultimately cheaper and more efficient.